Hello everyone and welcome to Machine Learning, AI and Robotics tutorials. In this tutorial, we explain how to correctly install and run locally Genesis on a Windows computer by using Windows Subsystem for Linux. For those of you who are not familiar with Genesis, Genesis is a physics platform designed for general-purpose robotics, embodied AI, and physical AI applications. It's a very powerful and easy-to-use simulation environment for simulating robotics systems. It can be used for verification of control algorithms, as well as for reinforcement learnings, as well as for computer vision and other applications. In this tutorial, I will explain how to properly install Genesis on a Windows subsystem for Linux. I'm running Linux Ubuntu 24.04 through Linux Subsystem for Linux. For those of you who are native Linux Ubuntu users, I created a separate video tutorial where I explained how to install Genesis on a native Linux Ubuntu machine. And here is a brief demonstration of how Genesis works in practice. Currently, I'm running Genesis in a Windows Subsystem for Linux and I'm simulating a robot. This is a Franca Amica Panda robot, which is a collaborative robot. Here we are simulating motion of robot. First of all, we are independently controlling joints, then we are controlling velocity, and finally we will show what happens if you don't send any control commands to the robot. Robot will simply crash. Note over here that this simulation is executed by using my NVIDIA CUDA graphics user unit. However, you can also run it on CPU. By the end of this tutorial, you will be able to install this simulation software on your Windows subsystem on Linux, and you will be able to run it. Okay, let's start. The first step is to install Windows Subsystem for Linux. To do that, click over here and search for PowerShell. And then run as administrator PowerShell, click on yes, and then over here we need to run a single command, and this is the command. Okay, so let's copy this command, and this will install WSL or Windows Subsystem for Linux. This will install the default version of Ubuntu that comes with WSL, and later on we will have to probably change the Ubuntu version or install Ubuntu 24.04. So let's be patient and let's wait until this step is completed. Okay, this will not take a while. After this, we will most likely have to restart our computer, but let's see about that. Now we're installing Ubuntu. So let's see what happens. Okay, launching Ubuntu. So this might take a while. Here you're creating a username. You're setting the password. And then you're retyping the password. Okay, so I made an error here. Okay, so let me retype this password. Okay, and that's it. So let's see what is this version of Linux Ubuntu. Here it is. It's Ubuntu 24.04. Good. Now, in my case, since I have probably most likely recently installed WSL from scratch, I didn't have to restart my computer. However, in your case, you might have to restart the computer after typing WSL install. A nice thing that WSL comes with the default Linux distribution. So let me show you what happens when you want to install a specific Linux Ubuntu distribution and how to do that. Here, let's exit by just simply typing exit. And here, if you type WSL list online, you will see all the available distributions. And if you want to install a particular distribution, you will simply type the following. Namely, you will type WSL install and the name of the distribution. For example, if you want to install Ubuntu 24.04, you will type something like this, or you will change this if you want, for example, to install let me now minimize this so you can see what's happening. So if you want to install 22.04, you will type something like this. Good. Okay, now we can safely exit, and then we can start our Linux Ubuntu. Click here and click here on Ubuntu, or simply search for Ubuntu and you will see this default Ubuntu app. and you can start Ubuntu in your terminal. So let's make sure that the version is correct. Here it is, and we can continue with installation. The next step is to install NVIDIA CUDA compilers on WSL. So let's learn how to do that. The installation process is non-trivial, so be careful and be very, very meticulous and try to follow the steps that I will perform. First of all, go to Google and search for CUDA install Linux. And then here you will find this web page, or actually not this web page, this web page. Now this web page will lead you to CUDA toolkit 12.9, and I don't want that CUDA version. I want to kind of downgrade my CUDA version, so I will do 12.6 since I know the 12.6 might work. So let's click here on this one, then click on Linux, click here, and over here select WSL Ubuntu, select 2.0, select Debian the network, and these commands should be installed. How or run. However, before running these commands, make sure that you run this command in the terminal. So run this and then enter your password. Okay, good. Now we can continue. Here are the commands that we need to execute. So let's start. First copy this one. So let's go to the terminal and let's type this one. Then let's go with the second one. Then let's go with the third one. And then finally we have to execute this one. And this third one might be the longest one. And so let's press enter, and this should install CUDA toolkit on our Windows WSL, that is on our Ubuntu that we are running through WSL. And consequently here you need to be patient and wait until this command is okay, and that's basically it. However, if you try to verify that compilers are installed, that is, if you try to run this command, you'll see something like this. NVC not found but can be installed with sudo apt install NVIDIA CUDA toolkit. The reason for this is that the NVCC compilers and executables are not inside of the system path. To add them to the system path, make sure that you go to the home folder by typing this command and then type this sudo nano.bash rc, and let's open this file. So what is a .bash rc? Bash rc is a script file that is automatically loaded or executed every time you start a command prompt or terminal. And here at the end, you need to type this command. That is, you need to add everything to the path. That is, scroll all the way down to the end of this file and type this. This will actually save the path. That is, it will add the compilers to the path. So then press Ctrl O to save, then Ctrl X to exit, and now we are out. Now let's try it. We have to restart the terminal. So let's type this. Let's click here and then let's click on Ubuntu. And then let's try to do this. Let me now zoom in, NVC C version, and you should see that NVIDIA CUDA compilers are properly installed, and that's it. So let's continue further. The next step is to make sure that Python is installed on our system. Consequently, execute these two commands to update and upgrade everything, then enter your password, and it's going to take a while to execute this command. However, this is necessary since we want to have fresh installation. So let's wait and let's see how long will it take for this command to execute. Let's wait. It shouldn't take a while. So let's see what's happening over here. My suggestion to everyone is to run sudo apt update and sudo apt upgrade at least once per day to make sure that all of your packages are up to date. Or you can put these two lines and run them every time you open a terminal. Okay, not too bad. So let's type which Python 3. Oops, I don't have which Python 3, and you can see that the Python is installed, and this is normal since it comes by default with WSL. However, if you don't have Python, make sure that you run this command, and this will install Python as well as other commands for creating virtual environments. In fact, you need to run this command since I've just seen that Python 3 virtual environment and Python 3 pip are not actually installed. So let's now type something like this to see the Python version, and you can see that my current Python version is 3.12. Okay, the next step is to make sure that we create a workspace folder and that we create our Python virtual environment. Consequently, let's go to the home folder. In the home folder, let's create a folder called Gen. Let's go to the Gen folder, and over here in the Gen folder, let's create our Python virtual environment by executing this command. And here it is. And then let's source, or let's activate our Python virtual environment by simply running this command, and let's see what will happen. Here it is. Now environment 1 is active. Good. The next step is to install PyTorch with the CUDA support. To do that, open Google and search PyTorch CUDA install, and then click here on Get Started, and then select your version. Let's go with stable, Linux, pip, Python. Let's go with CUDA 12.6. And then let's execute this command in the terminal, and let's press it, and this should install PyTorch. Now, note over here that the complete PyTorch package is around 3 gigabytes, and consequently, you have to be patient and you have to wait until this command is executed. So let's be patient. And after approximately 5 minutes, PyTorch is installed. You can actually run this command and you can see all the installed packages, and you will see that PyTorch also installs a number of additional packages. Okay, let's continue further. Next, go to the official Genesis website and then click here, Control F, and search for installation. And then over here you have 2 installation options. You can run this pip installed. However, I don't suggest you to do that simply because here you will have to you will actually download and install a version that might not be the recent one. Okay, instead we are going to download directly from the GitHub and install it from GitHub, and this means that we will install the most recent version. However, before we can execute this command, we need to run this command in order to make sure that pip is installed such that we can install everything. Okay, it is. And then let's run this command. So let's copy this and then let's run this. And this should install, at least download the Genesis, and let's wait until this command is executed. So let's be patient again. And after approximately 5 minutes, Genesis will be installed. The next step is to run a Hello World program and to see if we can move our robot. To do that, go back to the GitHub repositories, do Control F and search for documentation. Click on documentation, then over here click on English documentation, and then go over here. Let's click on Hello Genesis and let's see if we can run a basic code. So let's copy this code, and then here you have several options. Here you need to create a Python file. You can either use Visual Studio Code or you can use Nano. Let's try with Nano, and let's call the code as test.py, and let's start here. Let's paste this code. Here it is. And then let's save this by pressing Ctrl O, press Enter, and then Ctrl X, and let's try to run it. So let's run Python 3 test.py, and let's see what will happen. Okay, now let's investigate and let's wait to see what happened. Okay, so far so good, no errors, no errors, no errors, no errors, building scene. Okay, so let's see, will we have errors with rendering? That's the main issue. So let's see. Now I can see in the background fan of my computer started working. This means that this is computationally extensive task, and you can see that only CPU is actually running. Later on I will show you how to adjust this code to run on your GPU. However, the CPU version is the most basic one. So let's see what will happen and how long will it take for this code to run. And now we're building the visualizer. So let's see. Let's see if everything is properly set up. And let's hope it is. Okay. Now we're building the visualizer. And of course, this is actually slower compared to other versions. Okay, amazing. Here it is. It actually works. Amazing. Good. So there were no graphical issues and we were able to run this program on a computer. So I will show you now what's happening behind the scenes. So let's do Control C and then let's again do nano. And let me just see the name. Yes, it is test.py. So let's open the file and let's explain what's happening over here. So first of all, here we are importing Genesis on this line as GS. And over here we are setting the backend. Here we are using the CPU as a backend. We are generating the scene. We are adding the plane. And over here we are loading the robot model. The robot model is Franca Amica Panda. And here's the file. In fact, this file is inside of the installation library. Then we are building the scene. And over here we are simulating. Since we are just loading the model and running the simulation and there are no torques and there are no forces, the robot just falls down. Let's now test the CPU, the GPU version actually. So let's change this and let's type this GPU. Let's save this by pressing Ctrl O, exit, and let's repeat again this and let's see what will happen. Now we should use our GPU. And let's see if, okay, so I can see immediately an error over here. Let me do Ctrl C and you can see immediately at the beginning, let me just see what happens. Lib CUDA so lib not found. Okay, so this means that this program was not able to recognize the actual GPU. Okay, this is the problem that we can deal with later. However, for the time being, it's very important that this code is running. So what happened here, we switched from CUDA to the CPU. However, on my Linux version, that is on the native Linux machine, and I installed this program on native Linux machine, I didn't see this problem. Okay, this is very important to know. Anyway, the code will run, it will just automatically switch to CPU version. The next step is to run the second code. So let's see the second code. So let's go back here and click on here, control your robot, and then scroll down and find this code. Copy this code. Let's copy this code and then let's go here and let's type just clear and do nano test2.py and let's paste this over here. Let me briefly explain what's happening inside of this code. And let's now just change this to, we can leave it as GPU. It will automatically just switch to CPU as we have seen previously. And then we can see, and let's go over this code. Here we are importing, we're setting the type of computation, we are using GPU. Here we're creating the scene, that is we're creating a camera. And then let's see, let's go down. Here we are adding the plane. Here we are loading the model. And over here we are specifying the node, or actually the joints that we want to control. Our robot has 7 degrees of freedom. Consequently, we have 7 joints. In addition to this, we have 2 finger joints. And over here, we are getting the list of all the joints. We are setting the positional gains. We are setting the velocity gains over here. Then we're setting the force and torque ranges for safety. Then over here, we are controlling the robot. First of all, we are hard resetting the robot. This means that we are moving without simulating dynamics robot to certain position. For that purpose, we use this function and we are specifying the radians for every joint and the meters for every finger. Consequently, we move the first and second joints to 1 radian, and over here we are closing for 4 centimeters. Then over here we are also experimenting, we are changing another position, another pose, and over here we are bringing robot to the base pose. Then over here we are simulating the dynamics. We are using the PD control. Again, we are setting the degrees of freedom, not the degrees of freedom, we are setting the position of every joint. Then here we are changing position. Here we are changing. Over here we are actually controlling the velocity. Here's how you do that. Control D of S velocity. And over here you can also control the force, and that's it. So let's save this file. Control O, save, Control X, and let's do this. Python 3 test2.py. So let's now wait and let's see how long will it take for the code to execute. Again, we're switching to CPU execution, and let's see what happens. Okay, now it's going to take a while again to render everything, to build a visualizer, to simulate the robot motion, etc. However, here we have to be patient, and here it is. Not too bad. Here's how a robot moves. This is really, really good. This is actually amazing. Okay, now, if you go back and if you go to this instruction web page and installation, here you have some suggestions on how to fix the GPU issue. So here, if you go all the way down, you can see this is the issue. And let's see what do they suggest. So they suggest something like this. Okay, fix. Check if libcuda.so and other CUDA libraries are in the lib folder. If so, update the library path with export. So we can even try this and to see will this work while our program executed itself. So I can open a new terminal, or I can actually go here and I can type this, and we can see that there is libcuda.so. It is there. However, let's see again. So they're saying something like this: export this thing. Let's add it to the path. Maybe this will work. Let's see. So let's go here and then let's copy this line by line. Export. Then let's see, what do I need to type? I need to type this thing, and this should do the trick, but let's see. Okay. Now let's try to run the code again, and let's see will the error persist. So let's see. Well, let's see, will it... Okay, amazing. So here's the fix. It works like a charm. Now you can see that I'm using my NVIDIA GeForce RTX 3090, and if I click over here, if I go on performance, you can see that my GPU is being used. You can see how much memory is used, not so much memory, however, it's working. However, I don't think for this particular model you will see any speed up. However, maybe for simulations that are in parallel or that have a number of robots, you will see a number of benefits of using your GPU instead of using CPU. So here it is, it works. That's it. Actually, you will see that the frame rendering is less. But anyway, it works, and that's it. Okay, that's all for today, and thanks for watching.